Okay, so I know I covered the Hello World program in the last example, in the last class, right? But today we will review more or less what we did, right? So this is kind of like the Hello World program, right? We have a function, there's no input, so there's no parameters, and there's no return statement. So that means it does not return a value. So then this is a function or a void function, does not return a value, right? So how do we use that function? Can we test it? No, we can't test it because it doesn't return a value. So how do we use it? This is an example for using that function, right? So if we go back and look at file input process output, we define a function with the keyword def, the function name, and then the parameter list, and meaning values that go into the function. There's none. Colon is required, and then we have a print statement that helps us display something to screen. Print hello. Okay, so we want to use this block of code in our main program. We have to use the keyword import, and we're telling Python, hey, code that's in the input process output file, I'm going to use it. This is how I'm going to use it. Input process output dot display output. So when we run this program, it should display hello, right? So that's, remember, like a non-value return function. It does not return any values. Okay, if we go back, we can create a new function. So I'll go here, and now I'll create a function that does not return a value, but displays whatever value we send into it. So I'll say def echo value, and then I'll say value, right? So this function, colon, and then here I'll say print whatever is in this bucket or this variable, display it, right? So then we're like, okay, echo value, and print the value. How do we use it? We already have an example for using it, right? So here we're like, okay, so I imported input process output already. That's where my code is, so I don't have to import it again. Now it's just a matter of telling Python where or what piece of code we want to run. So we say echo value. This function will accept a value, right? So we have to send it some value, and we're like, okay, so let's say like, for example, Python, right? We just want to display that value, Python. Why are we putting this here? Because this block of code accepts some input. So we go back here. It can accept some input, and then we can display that input, right? So here we're like, whoever wants to use echo value, they must provide a value. And when they give me that value, then I will display whatever value you send me. So if I go back here, notice down here, it displayed Python for me, right? It displayed hello because it's also it's running this piece of code here, right? So questions here? So we go back and look at this piece here, right? So input, hold values. The key or the name in programming is variable. And I said that a parameter is an input, so a parameter is a variable. Why is it a variable? Because it can hold different values, right? So here, like if we say C++, so initially it'll store the value Python and then C++. So if we go back and execute this piece, notice it's like, okay, you send me the value Python, this statement here, I will print it to screen. You send me C++, I will also print it to screen. Hence the word variable, right? But the name that we use here is, for this piece here, is a function parameter. Okay, so notice a parameter is a function parameter. And if you go over here, then this value here is known as a function argument, right? So the argument will go into the parameter, which is a variable. Okay, so let me go back here, and now we can explicitly create a variable, right? So so we'll say hello, right? And we'll expect some name. So hello. And then I will say here, I'm going to create a variable. So in Python, to create a variable, give it some name. So here I will simply say display value. That's the name of my variable. And then I'll say hello, and then I will use plus, meaning like whatever hello, whatever value name has, display it after, or add it to display value after hello. And then I'll say print display value. Oops. Display value will hold the value of hello plus whatever name is. So if name was Python, then it would say hello Python, right? I'll put here if the value that the name variable holds is Python, right? Just to make sure that we understand that. Does it return a value? No. Notice here it does not return a value. Okay, so then we go back here and we can try to run it. So input process dot say hello, and then we'll say hello Python learners or something like that, right? Okay, so let's try to run this piece up here. Run. We are interested in the last output statement, hello Python learners, down here. So what happened? So we sent the value Python learners, and then name has the value Python learners. I create a new variable, display value, and I'm like, hey, display value, the value you hold is hello plus whatever the value name is. And then the print statement will display whatever is in this bucket or in this variable display value. And that's what we did right now. So questions so far? So when the book is introducing you to functions, what I mean when I say they write everything here, they do not use functions, right? So they'll be like, oh, by the way, this is how we can create variables, right? I'll say like name equals Python learners. So now we create one variable here and another variable here that has the value hello Python learners, and we display the value Python learners. So if we go and run this piece, it still displays Python learners, right? However, in this class, we stay away from writing code like this. Instead, we opt to use functions. We will create variables in main sometimes, right? But for now, we're creating functions and we send values to functions. Why functions? Because functions help us organize code, and then we can reuse that code, right? So if we're using, for example, like a function that's calculates some value, right? And then that function's used a lot in our program, then we only have to create the code one time in a function block, and then we can call the function more than once. Here we call it one time, and here we call it another time. If this program was large and it had different files, then we could call it a lot of times in different files. So that's why functions are useful. Questions so far?
Just a quick question here. Do you not have, once you declare your variables, like the variable type, because I've seen in other programming languages where you have to declare the
Yep.
type.
Yeah, so good question, right? So I think that was Brian, right? So Brian is asking, so this is creating a variable here, right? In other programming languages, you have to tell the programming language the name of the variable and then what type or data type you are going to use for that variable. For example, in C++, if you wanted to work with whole numbers, then you would use the keyword integer. So then in C++, just an example, right? Like say num equal 5, right? So this here would be creating a variable of whole number type with the name num that holds the value 5. In Python, you just create a variable, you give it the name, and Python, from the value that is given, decides what data type you are using. So in this case, we're using sequence of characters. So that's commonly known as a string. So that's a string data type. We don't have to worry about that. Like Python will take care of that for us. Can we test say hello? No, because it is not a value return function, thus we can't test it. So if I'm like saying, hey, like I want you to test your code before using it, how do we work with functions that don't return a value? Like how are we like expecting that code to work? Well, the key thing is anything that's sent in as inputs hopefully went through value return functions, which we can test. And then when you're using a void or non-value return function, all you are using it is to display something. You're not wanting to perform calculations here because how do you know the calculations are correct, right? So hopefully you would have a list, like for example, of paychecks, but it would have all the calculations performed in a value return function that was tested, and then you would just send that data here to maybe like display checks, and all it would do is display. It wouldn't be like trying to calculate gross pay, net pay, all the other kind of taxes, right? That would be done beforehand. Okay, so let's create one more example with a different variable type, right? So we say so def or create a new function, and we will give it the name, what can we, some arithmetic operation, right? So we're like, okay, so maybe like add values. I think I did that. So we'll say, okay, add values, and we'll say num1 and num2, so add values. And we'll create one variable here. We will say result equals num1 plus, the value of num1 plus the value of num2. And then we'll say print the result, right? Very simple example. It doesn't print a value, but notice I'm already like doing calculations. So it's kind of like, hey, wait a minute, like you told us not to do that, right? So I'm like, oh yeah, so we can't do that. So then here I simply say return result, right? So I'll return the result. So now I can test this function, return the value to make the function testable. Okay, so now we're like, oh, okay, so we have add values, and now we want to test this add values function. So we're like, yes. Okay, so let me go to the test case, right? So we are in src examples, b input proc output. So then we have to go follow that structure here, right? So we're like in the test folder, examples, test input process output, right? And we're like, okay, so here I'm like, I can create a new function, right, that tests something. So I'll be like def test at numbers. Self is required. Later on, you'll understand when we get to classes, you'll understand why it's required. Right? And self-assert is required. We say, okay, I want this. And then I'm like, okay, so what do I want to do? I want to test add, what did I say? Values, numbers. Let me go back. Add values. Okay, I want to test the add values function, and I want to add values 3 and 4. That should give me the value 7. Notice right here, like I have that yellow underscore, and it's telling me I do not know what add values is, right? Add values is not defined. So the IntelliSense, the code helper, is telling us if you try to run this, it's going to fail because add values, I don't know what that means. So then we have to hover over quick fix right here. And then notice here, like it's smart enough to go into that file input process output in the source folder and tell us, oh, I found the function add values in there. If I click on it here, notice it adds it for me here. And now it knows what add values is. Okay, it's a function that can accept num1 and num2 and return some value. So here I'm like, oh, okay, let me see if adding values 3 and 4 gives me the value 7. Can we run the test case from here? No, if we try to run it from here, we'll get this error, right? So meaning like, I'm not sure what you're doing. We always run tests from the file runtest.py. So we have to go to runtest.py. And let me see here. So here, it's going to run the test case file that's in the folder test examples, a example, and the file name is test dev process. We don't want to run that file anymore. We want to run the file that's in B input process output, and the file name is test input process output. So now I have to go in here and say, okay, I want you to go now to B input process folder, and in there you should see the test input process output file. And then we copy this value and we put it in here. It's required, right? For now, that's all that we need to understand. It's just required. Now, that's what the professor told me, right? Later on, we'll get a full understanding of what this is when we learn more about classes. Now, I should be able to run the test case. Let me do clear here, clear down here, that are in test input process output. It should run test at numbers and test configuration, right? Only from runtest.py. So I go here and I'm like, okay, let me try to run it. And I run it, and notice it's saying that at numbers is okay right here. So my test case successfully passed, meaning this code that I created here, add values, result equals num1 plus num2, is working as expected. Now I can go and use that code in my program, right? Maybe here in main. So I can go here and I can say, create a variable here. So I'll create a variable. I'll say, okay, create a variable and name it result equals. And then we want to run something from input process.output file, and that adds values. And for now, we'll just send in values like 5 and 5. So we create a whole number variable. Why? Because we know that this is a whole number, this is a whole number, and whatever add values does to them, it'll return the value 10. And the value 10, we want to save it into this bucket, into result, okay? So then we want to print whatever value is in result. So this is a case where we can create variables in main, right? Or program, but use it in functions, right? And let's go ahead and run it. So the last value we're going to be focused on, right? That should be the number 10. So I can go up here and notice value 10 down here. The last value here is 10. So step by step, let's forget about this piece, right? Our program starts running. We tell Python, hey, input process output file, load it. They're like, okay. And then we're saying Python create a result variable or bucket. In the file input process output, find the function add values 5, 5. I want to send the values 5 and 5. Python's like, okay, let me go and make sure that exists. So it goes into our input process output file, scans our functions, and it's like, oh yes, I found it. Add values. So num1, you have value 5. Num2, you have value 5. Oh, you create a new variable result in here? Yes. Assign it the value num1 plus num2. Return the result. And then it's 10. So then there's a different result variable here. We store the value 10, and then we're like, hey, like display whatever values in result. Key point here, add values was tested. Okay. So now we are okay. We trust that values. We're like, hey, this has been tested, so we trust it. We can just use it, send it values, return the value, and now we can print the results, right? So questions here? Okay, so now let's try to use add values again. And this goes back to Brian's question, like, do we when we create a variable, like here we create a variable, we just give it a name, assign it a value. Python understands how to work with those variables behind the scene, like what kind of data we are using, right? So assume I'm like, hey, now I want result to be like some value, oops, reusing. Okay, so then print. And let's see what happens, right? So notice these are numbers, whole numbers. This is a sequence of characters. The computer distinguishes, right? It's like us, like we know like the alphabet is alpha, and then the numbering system, they're numbers. So we distinguish them, right? With numbers, if we classify them as numbers, we can use them in mathematic or arithmetic operations. But we can't do that with alpha or alphanumeric. If we consider something like, okay, you're a number, but you're used in the alphanumeric piece. So then the computer does not treat this one as a number, meaning we can't like say, hey, add something to this. Like the computer won't treat it as a number in the numbering system, so we can't perform arithmetic operations on them, okay? But let's run this example and let's see what we get. We are focused again on the last two outputs. It should be value 10 and then something else. Let me clear here. And let's run here. So we're focused on the last two outputs, and notice we have Python is flexible with reusing variables. The number one is just there for what I just said a little while ago. But notice like at first it was a whole number, but then we can use it as alphanumeric. In other programming languages, you can't do that. Like if you say that a variable is going to use numbers and you try to assign it like a value that's alphanumeric like this, it will generate an error. Okay, so we need to be careful with that. And here Python, I guess they made it very flexible so that it could attract a lot of new programmers, right? Like you're just like working maybe at an office or at a place where they don't have programmers, but maybe you need like to create some simple program, then Python would be a good place to start because it's very easy for newbies, right? So I think that's why they made it very easy for new programmers. Questions here? Okay, so let's try to reuse it one more time, right? So we'll say result equals, like we'll say maybe like just assign it some weird value. And then we print result just to drive the point home that Python takes care of what it is behind the scenes, right? We'll say result. And then we'll say result equals result plus, I don't know, some, and let's see what we get, right? Just to see like, will it allow us to perform arithmetic operations on it? So let's run it. Notice it does, right? So it was initially whole number, and then we used it as alphanumeric, and then we're like, hey, be a decimal, or the term in programming is float, be a float. And now we're like, hey, like get the value of result to 150 and save it back into result. So we, in essence, overwrite 1099 with this calculation. Okay, questions here?
So if I'm understanding this correctly, we assigned the result to 10.99. Then and then on line 18, we added that assigned result to 150. And then on line 19, it printed the sum of those two values.
Yes.
Okay. Okay. I was just trying to understand the
That's
code,
fine.
like
Yeah.
what this all means and all that.
Yep. Yeah, so I did this because I was saying that like they're treated as numbers. So if they're treated as numbers, we can perform arithmetic calculations. But maybe what's a little hazy is this piece here. Like when I'm saying alphanumeric and that one is alphanumeric, and then the Python programming language will not let us perform calculations as we know in the math numbering system. So what does that mean, right? So maybe here we're like, okay, result equals, we're gonna make 1099 alphanumeric, right? And then we're gonna say a result equals result, and then we're also gonna make this one alphanumeric, or the word for it in programming languages is string. And then we're like, let's print this to see what we get. Like, what are we gonna get, right? So what type is it? 1099. So what are we gonna get? 1249 or some other value, right? So that's what we're looking at the last two values. So let's go up here, run it, and notice it does 1099 and 150. So it stitches them together, but it's treating them as non-numbers. So then it's just, oh, this is a sequence of characters. So you want me to put them together, and I did, right? 10.99 and then 1.50. So it didn't treat them as numbers, so we can't perform arithmetic operations on them. That's what I was trying to say here, right? So hopefully that clears it up. Questions here? Okay, so let me see here. Yeah, it concatenates them, right? Okay, so now what I want to do is I'll eliminate this one, right? Because I think this one drills the point home. Let's convert this pieces here to functions, right? So that we can see, like, I know the book would do it like this, but how do we do it with functions? So we'll do a function. So let's go here And actually, we already have add numbers. So, oops, not there. We already have add numbers. So then we can go back and be like, oh, okay, so can I do input process dot add values, and can I add whatever value result has to 150? And will that still give me 1249? Let me eliminate this for now. So now notice we send in the value into a function, and then we're like, hey, like you are 10.99, you are 150. Add those two values, save them into the result bucket, and then show me the result. Will it still be 1249? What do you all think? Let me see here. Yeah, hopefully, yeah, means yes, it will be 1249, right? So let's see. Yeah, 1249. So it was able to do that. What about with the strings, right, or the sequence of characters? How would it hold those? Let me do Control Z here, bring that back. So I have result 1099, and then I'm like, hey, can I use the add values with a sequence of characters? So whatever value result has, feed it in here. And then I will say the value 150, but not as a numeric number or whole number, but as a sequence of characters commonly known as a string. And let me clear this section here. And let's run it. So run. And notice I get the same output as before, right? So again, just showing the flexibility of Python, that even though like here we're saying add values, like we can send in a whole number, Python will be able to handle it. We can send in a whole number's integer, right? Or we can send in decimal, which is float, Python will handle it. We can send in a sequence of characters, strings, Python will stitch them or concatenate them together, and we get the same results. And now we're exclusively using functions to do our calculations or concatenation. Question here? Okay, so let's go back to the test case. And we're like, oh, okay, so let me just make sure that I include what I just learned in here. So I'm like, add values, and I use what, 1249 and 150. I'm just gonna copy, and then I used 1249 and 150, and this should be actually 1099, right? 1099, and this should return the value 1249, and then this should give me back a sequence of characters or a string of 1249 and 150. And I will run this test case. I cannot run it from the test file. I have to go to run_test. And now I can run it. So go here. And notice it's still telling me that add numbers is okay. So that shouldn't be a surprise. We had already like demonstrated the flexibility of Python here, but it's always good practice to include them in our assertions for our test case, right? So this here, all this together is one test case. This is one assertion, this is another assertion, this is another assertion, right? So that's the lingo for that. Questions here? Okay, yeah, so again, the book doesn't talk about functions till chapter 5, but I'm a strong believer that I'm just going to show you what you're going to see out there when you go work. The more exposure you get to it, the more comfortable you'll be with it at the end of the semester, right? So that's the whole goal here. Okay, let me